Hello and welcome to our presentation on marking. The group members include myself, which is Hannah, Katie, and Amber, and our subtopics include camera traps, photos of unique marking, and radioisotope tags. Up first will be camera traps. Hello, my name is Hannah Bell, and I'm going to be presenting on camera traps. So probably a lot of us are familiar with camera traps, whether we use them in our own life for maybe hunting, or we've seen the end product of the pictures that are captured, but they are cameras that are automatically triggered to take pictures or videos. So that means that you go, you set them up, and then you leave them out to take pictures or videos, whatever you've it set up for. And we use them in the field a lot for research, whether it's research on conservation efforts or how they're interacting with each other or how they're breeding. There's lots of different reasons why we would want to do research and collect data from camera traps. Here is a pine marten, an example of a camera trap being used for a photo. Here are two examples of camera traps. They really range in size and make and cost and a bunch of different things. So you can look for that. And then here's an example of how you would maybe set it up out in the wild to kind of camouflage it so that maybe wildlife won't know that it's there. Can work, doesn't always. And here's some more pictures of camera trap photos. So here's a porcupine, here's a red fox with a pheasant in its mouth, and this is a cool one. It's a female snow leopard with her two cubs, all caught with different camera traps. So now some pros of camera traps. They do have less human interference and they're considered less obtrusive because we're not physically out there taking the pictures ourselves. Again, we use them to collect research and data, which is becoming really important in recent years, especially this year with COVID-19, people not going out relying on camera traps, but they could be to do a population estimate. It could look at that intra-community relationship between species and looking at the ecosystem as a whole, as well as it's really important in nocturnal animals and figuring out their behaviors or seeing how they're doing since it's hard for us to observe them at night. It can help us with conservation and figuring out what the population is, what to do going forward, as well as maybe giving us some good management practices for populations that are struggling, or maybe for a habitat that we notice needs restored or something like that. And with climate change being so important, it helps us show, or it helps us see how these animals are interacting with their changing climate, whether it's weather that's changing or temperatures, different things like that. Here's a bobcat caught on a camera trap. And there are cons to it. There's lots of technical cons, so I'm just going to kind of go through them really quickly. Trigger speed delay and recovery time are both like how long will it take for it to take another photo or to take a photo when something steps into the frame. Flash versus no flash. Flash helps you capture nocturnal animals, but it is obtrusive and is a disturbance versus no flash. You might not get as good quality pictures. The battery life is always important to know. And there are disturbances that we can and need to know, and that could be sound when it takes the picture, or it could be that flash, or it could just be the camera itself. It can be obtrusive and the image quality. You're not always going to get a perfect image with camera traps. So here's a wolverine, and here's an example of two poor quality images because either the animal is too close to the frame, it's too far out, it's not looking at the frame, it's not centered, different things like that. So you have to remember you're going to get a lot of different qualities of images and you might not be able to use them all. Now, some examples of them being used: wolverines have a small territory where they live, they're very elusive, and so we want to figure out how many there are, kind of how they're breeding, what they're actually eating, and they are predators and scavengers. So that's important when setting up a camera trap because you're going to use bait. And so in Wind River Indian Reservation in Wyoming, they set up a trap with a dead deer hanging up by a tree to hope the wolverine would come. And one did. They caught it on camera and via video. And though the wolverine knew the camera was there and ended up moving it, pushing it to the side before it left the area. Here's the link to the video. I highly recommend it because it's very unique and very rare. Now, National Park Service also uses it all over the US, but the Greater Yellowstone ecosystem uses it to look at white-tailed deer, coyote, and pronghorn antelope, and they want to see how they're moving and how their population is doing, different things like that, how they're interacting with other populations and species. In the Santa Monica Mountains, they're using it to look at mountain lions and to keep a population count of them to see how their population is doing. Here's a camera trap photograph from the Greater Yellowstone ecosystem showing a pronghorn antelope actually leaving the park and going out onto farmland. So that is my presentation on camera traps. Hopefully you enjoyed it and learned something. And here's my works cited. Thank you.
All right, hi everyone, my name is Katie. We're going to be talking about marking and tracking these individuals through scars. So scientists have been using these types of markings for quite a while in terms of tattoos, dyes, telemeters, and satellite radio telemeters. And so like this bird here being banded, scientists have kind of unnaturally added something to the animal in order to recognize them in the wild. But what scientists are learning is that some animals have very distinctive scars. It might be like with the sea otter, who has a nose scar, and this is fairly common amongst their species. And so they're using that to identify them in the wild. But then on the flip side, we can see the Florida manatee, that it does have a very traumatic experience to gain these scars, and it's unfortunate, but scientists are now using that to track these animals. So why is that a better idea rather than to just mark them or band them? Well, when you do this, you do have to capture the animal. And unfortunately, that can be risky in finding that they may be harmed during the capture, or it could alter their behavior, which is ultimately going to alter your results and skew your data. So the Florida manatee is a very common species that is marked with scars and is tracked this way. So the Florida manatee was endangered. Now due to conservation efforts. They are actually only threatened now, so that's a really good success story. There are West Indian manatee subspecies that can be found throughout Florida and all of these green regions. So because the manatees uh, are endangered or are threatened now, it's due to human entanglements by different ropes, wires, fishing line, and it's also due to propellers on boats. So manatees hang out in springs, warmer springs during the winter months, because they cannot actually live in water that is cooler than 72 degrees. And unfortunately, boats will come through these areas in the wintertime. The manatees, because they are marine mammals, come to the surface to get air, and then they're struck by these propellers, which give them that very distinctive scarring. So what scientists have started to do is actually use these scars in a positive way. Since the scars are already there, there's no marking that needs to be done. They don't need to be captured. They can simply be observed. They can be observed by a citizen scientist such as myself for Save the Manatee Club here in Florida. We can take a chart that looks just like this one here. And when we see a manatee in the wild, we can simply draw the line on his back of where that scar is. I can then take this document, upload it as a PDF, and submit that to the catalog, which is statewide. And we'll talk a little bit more about that in just a moment. So just to familiarize yourself with a couple of examples here, this is Whiskers. So he has a scar back here on his lower back. That can be shown here in this chart. And then Doc has these three distinctive lines here and then one there that you can see in this chart. So these manatees are already in the catalog. However, it's still important for citizen scientists to report that data. We want to know where Doc and Whiskers are migrating. Where are they moving? What are their foraging habits? What are their behavioral patterns? We want to know all that, and this is a great way to mark where these manatees have been observed in certain parts of the year and where. So once that is put into this catalog that I keep talking about, that is the Manatee Individual Photo Identification System, or what we call MIPS. So this would be with the U.S. Geological Survey SERENA project or the Florida Fish and Wildlife Conservation Commission. So all that data is given to them that create a catalog, and hopefully will continue to broaden to have more manatees across the state of Florida. So we can observe them. This is more how I would do this in the field, by kayak or paddleboard. But due to serious injuries, Save the Manatees Club or SeaWorld will use these methods to capture them and to rehabilitate them. And then at that point, we still take the photograph, we still get that data on their scars, and then they can be safely released into the wild when needed. And that would be the same with this orphan as well. This information is critical because we do need to understand their migration patterns so that we can reinforce some of the rules that we have here in Florida about manatee safety. We need to know where they're moving at other parts of the year. We also need to know where these markings are coming from so we can identify them as propeller scarring or from entanglement. So just understanding their history, their behavior, their foraging, we need to understand all that information. And this is a good, effective, and safe way to gather that data. This is my works cited. Thank you.
Hi, my name is Ira Wheeler, and today I'll be talking about marking with radioisotope tags. So first off, just a little background. Advantages over mark and recapture for isotopic labeling as a method are their large sample sizes, eliminated the need to recapture it, saved time, money, and energy. It's a great method for carnivores. This is also a slow-release drug. Delivery devices such as implants were revolutionary. Some examples that have been done before include bears, raccoons, deer, rodents, game birds, etc. So slow-releasing radioisotope implants as individual markers for carnivores, Crabtree 1989 is the paper that I chose. And the implant material is polylactic acid, and also known as PLA. And this is what it looks like over here. So this is the PLA. It's biodegradable, and it's the most widely used and understood. It's slow release, and it breaks down into lactic acid, which is a natural metabolite for muscular contraction. And mixed with available radioisotopes such as zinc, cobalt, cesium in a hydrochloric solution. So in this paper, they used 6 different radioisotopes to determine which was the best for radioisotope marking. They were individually packaged and distributed, and they were tablets that were implanted into the upper shoulder regions of coyotes. They did initially do this in the lab with 2 coyotes in a controlled setting, and then moved to field testing on 25 captured coyotes. They implanted with 1 or 2 PLA implants of the exact same isotope. Each had a radio-transmitted collar, such as this here, and they radio tracked them for 3 months, and then the scats were collected for less than 2 years. The results, there's always variance. Of the 6 isotopes, zinc and cobalt were the most extreme. Initial high peak for cobalt in urine is the only strong urine marker of all 6. Peak for zinc was more severe due to long retention time, and ultimately zinc was decided as the ultimate radioisotope to use in terms of tracking feces. However, all appear to be acceptable. Research applications. The population and group size estimation, it's more favorable, there's no need to recapture, and that eliminates recapture bias. The assumption is populations are closed to ingress and egress. However, this is false, but it can provide a relative measure of closure violation. And as seen here, this is the initial home range, and the radio collars help to monitor movement and actively determine the owner of the scat. Only scats used were those marked as full-time residents for abundance calculation. And as you can see back here in this graph, all of them were marked as acceptable, with zinc being the best. Home range and diet. So it provided an alternative to determine the home range, and this is the home range over here for a 4-year-old territorial male. And the correlation between habitat use and diet, they were able to see through the scat that whether they were involved in depredation of rabbits or just in terms of like how they were actually making use of their habitat. In terms of social behavior, not much was concluded. The amounts of the radioisotope within the urine and scat were too low in order to be actively observed. However, the implications on management of PLA, lower levels of radioactivity, increased handling stability, longer lasting marks, many individual marks, and constant release rate in feces. How it does pose a warning is it can be a hazard if left too long unattended, and also in too large of a dose. Thank you for joining.